if you have an idea and a thought and a concept, you should follow it and search it out, see what you can get from it. That's what happened with STELCOR. Nobody told me I couldn't do it. So I just thought through it, thought of all the elements that I wanted and needed, figured out a way to introduce them, and created what a friend in the industry, a well-respected person in the foundation industry, told me was the most advancement that the industry has seen in 65 years.
Yeah, I think so too. Good afternoon. It's Kevin Lathan here with Ben Stroyer of the Ideal Group. We're here for the Pile Buck Magazine podcast. And Ben, it's a real pleasure to meet you. I know that you've got a long tradition in your family as builders.
My father and his father and his brother started in 1956 in construction, general construction. So we grew up in a large family and just became part of that program. He was really, I would say, more of a craftsman than a businessman, if you know what I mean. He taught us fine quality work and honesty and integrity and hard work. So when my brother and I, Art Jr., got a little older, we decided we would get involved in foundation repair. And that evolved into helical piles and underpinning. In fact, we underpinned so many buildings and homes in Amherst, which is a town in Buffalo, about an hour and a half from us, that we had the Army Corps of Engineers. Yeah, we had, I think it was 5 of those guys came to see us, and they showed us a map. They brought us a map that they had prepared, and all the red dots were the projects that we had done when we were in the construction part of foundations. So that was kind of interesting. So we came up with solutions to save the houses in Amherst. And then from there, we started designing our own pile underpinning brackets. And we started building helical piles and got out of the installation side. And from there, we became the first to do high capacity helical piles in the U.S. The Canadians were the front runners. They'd been doing it for the oil fields, and they're really good at it. But we were the first. We have a 32-story building that was done probably 11 years ago, sitting on helical piles in Jersey City.
When you're looking at a project, Ben, how do you decide what kind of foundation it needs? Certainly, it's based on the local geology and some history thereabouts. But what's your approach when someone says, "Hey, I need this building or this bridge, and this is the capacities"?
Yeah, so I mean, obviously, a shallow foundation is the least expensive. So if the soil is decent, then you and can bear the loads of the new structure, then you would just go with a spread footing or a shallow foundation. But where the loads exceed what the ground can carry, then you need a deep foundation, a pile foundation, as you're well aware. And then there's a wide range of deep foundations that can be used to support a structure.
What about frost heave on raft foundations? How do you address that? Because you're in Rochester, New York. Would a helical anchor provide tension to combat that? Does that make sense?
Yeah. So where we are, I mean, the annual average snowfall is 111 inches. So we do get our fair share of cold weather. Yeah, so I mean, a raft foundation, of course, is something entirely different. A raft foundation is really a foundation that's built like a large mat. I don't know how to explain it best, but just as you would walk in the snow has a certain bearing capacity, and when you step on it with a regular boot, you're going to sink down 5 inches and you're walking in a foot of snow. But if you walk with snowshoes, you're going to spread that load out, and the very same snow will only allow you to sink an inch, right? So
It's a
yeah,
perfect analogy. Yeah, that's it. You nailed it. Yeah.
that's the idea of a raft foundation. Um, so a deep foundation obviously is much different. It's taking the loads to a load bearing stratum that's deeper in the ground. And you're absolutely right. I mean, a building is only as good as the foundation that it's sitting on. If you don't start with a good foundation, your building is always in question. And we really drive that principle into our lives and into our business as we build it.
Right. So with the helical pile, that's I don't know if that is identified as end bearing or friction pile. It's kind of a combination of both, I think, because there's only those two. Either when you're driving a pile and trying to support something with a deep foundation, it's either relying on the geology for friction or it's end bearing. Most of them are friction, but where the helical pile might be a little bit of both because a lot of the bearing is on the threads essentially. I'm not sure how that's categorized.
So a helical pile would be considered an end bearing pile
Right.
generally.
Okay.
Generally speaking, there's a direct correlation between the installation torque and the ultimate axial capacity. So it's you're getting an indication through a torque meter or inline hydraulic gauges that tell you pressure, right? But you're translating everything to torque. And so you're understanding the resistance that the helices, that's the plural of helix, the helices, if it's more than one, are meeting as they go through that soil. And so, yeah, definitely it's considered an end bearing pile. It's whatever those individual helices, the soil that it's bearing on, is pretty much what you would consider the capacity of the pile. There is a situation where if you have a large diameter helical pile, you begin to generate some skin friction, just like you would with a driven pipe pile.
Is there things on the horizon that you see for tension indicators in helical pile technology in the future?
There's pretty good equipment on the market that gives you your torque ratings, which translates to axial capacity and compression or tension. And as you say, it's an approximation. It's not perfect. When we, it's pretty accepted in the marketplace up to I think 3.5 inch OD piling. That is the central shaft I'm referring to accept the torque as a verification for axial capacity. Beyond that, I mean, anything we do generally in the high capacity, they would always be load tested in
Right.
series. Yeah.
How does that? Tell me about the STELCOR because that's really when I met your brothers some years ago, and I learned a lot about that. I've got an ideal group book here from a decade or more ago, and I always thought that was just a genius idea. You get a lot of there's still a lot of work out there for the STELCOR.
Oh yeah, that's growing exponentially for a good reason. So yeah, so the STELCOR pile that was developed from a need that I saw in the market because we were manufacturing strictly helical piles for years, and there was the grouted pull down pile where you have a helical pile and you put some grout around the shaft to enhance its lateral capacity. It's being used to enhance compression uh, capacity as well, which I have a problem with, and we can go into that a little more later. But to use a smooth shaft and expect that to transfer the load suitably through the grout and into the soil seems insufficient to me. But in any case, we didn't have a pile that we could use for friction. And so anytime there was loose soils, maybe down, I can give you a specific example. We had a project where they were installing a competitor's helical pile, and they were hoping to go 35 feet. It was for an adventure outdoors. I think it was in Georgia or somewhere like that. And they they were installing a helical pile, and they were at over 100 feet, and they couldn't get capacity. They couldn't get resistance. So in desperation, the contractor accepted my proposal to install STELCOR. And they installed STELCOR to 21 feet and got the loads. So, so we saved the project, we saved the owner hundreds of thousands, and the contractor actually made more money because he could move faster through the project.
Now that Stelcor bit, is that sacrificial? That stays in? Is that how it works?
So the whole entire pile is sacrificial. It's just like you screw it into the soil like a helical pile. So I tried to use all of the same methodology for installation because that was my client base at the time. Now it's gone way beyond that into all kinds of pile driving companies. And but essentially, you have at the tip there's a what we call a displacement head, and that has a helical blade or a bearing plate. And as you turn the pile in, just like a helical pile, it advances it in the ground. But as it's going down, there's lateral displacement fins that push the soil outward and make an annulus around the pile shaft. And and then beyond that, there's a secondary deformation fin that cuts a groove in the soil to increase the friction coefficient. And this is introducing grout as the pile is advancing. So all this is happening simultaneously. There's no opportunity for cave-ins. So it's not like you're making this annulus and then filling it. No, it's all happening at the same time.
So you're feeding the grout through the central pipe that is connected to the steel shape. That's a cone shaped tip that works the displacement. Is that how you're feeding it? So you're bottom feeding the.
So you can do that. We do not normally do that. We have through the entire length of the central shaft, we have grout ports, so the grout can move freely from the outside to the inside of the pile.
Okay. Okay.
Then the seventh feature of the STELCOR, and all of these features are patented in some way or another, but the the seventh feature is a reverse auger. So if you have a right hand plate on the base of the pile, as you turn it clockwise, it's advancing down into the soil. Then for the entire length of the pile, there's a reverse auger, an auger that's turning the opposite direction. And that does not touch the soil. That's fitting within the annulus that you've created by the displacement head. So that reverse auger is flushing that annulus and the deformations with grout simultaneously through the entire installation. The grout is introduced at the top, so there's no pressure that's forcing. Remember, we're creating the densification of the soil through the displacement head. So
Right.
there's no need for us to put it under pressure. And
Okay.
furthermore, we don't want it under pressure because you could lose a lot of grout off into a soft vein somewhere.
And you're also into micropiles. Where do micropiles play in all this?
So the STELCOR pile has been called a lot of things, including a drilled in displacement micropile. So that's how we're in micropiles.
Oh, okay. Okay.
It's called a bunch of things. It's now in the New York City Building Code as a displacement pile. So that's helped our acceptance. We've been installing in New York for many, many years. We were at the JFK airport doing piles. We've done federal work, Air Force bases, a lot of a lot of really nice projects. But you and I were talking about as part of this conversation to talk to younger people about getting involved in construction. And if I could just divert to that just for a minute while we're on this subject of
Oh,
STELCOR.
please do. It's very important.
One thing I would encourage is young people is to not to be, I don't know how to put it, not to be held captive by the established and acceptable norms in an industry. If you want to, I know it's cliche thinking outside the box, and I would just say that you need to not be bound by these ideas that certain things are the way they are and they will remain that way forever. If you have an idea and a thought and a concept, you should follow it and search it out and see what you can get from it. That's what happened with STELCOR. Nobody told me I couldn't do it, so I just thought through it, thought of all the elements that I wanted and needed, figured out a way to introduce them, and created what a friend in the industry, a well-respected person in the foundation industry, told me was the most advancement that the industry has seen in 65 years.
Yeah, I think so too.
Becoming more prevalent, the need for deep foundations, because all the good soil is the nicest ground is used up first, right?
That's right. Yeah, that's where a lot of the expensive real estate is. We got to build more. Yeah. So
I think one of the other things that could be said to encourage folks that are that have an inventive mind is if you want to succeed in the marketplace, there's almost no end of good ideas. If you look at the patent records, there's millions of patents that have never come to anything in the marketplace, and there's a reason for that. And it requires drive behind an idea, for one thing. But another thing I would caution against is don't be too radical. When you're dealing especially with engineers in the building industry, you're dealing with people's lives and you're dealing with safety issues. So one thing that helped us with STELCOR is we were able to convey to the engineering marketplace is that really we don't have anything all that different. We've got steel and grout interacting with the soil. It's just a different methodology for getting it there. And it happens to be very fast, very clean, and very efficient.
yeah, and provable with load tests and torque and everything else, right? And the proof is in the pudding. So now you've got a long track record. You're developing new materials, but you're also fine tuning and providing the equipment for the installation to try to improve on that. What's going on in that marketplace? How does that work?
I can't say everything about it, but we are developing and patent application for a means of in situ theoretical output for capacity of a friction pile as it's going in the ground. So that's never, that I know of, been done before. So we're excited about that. What it means in plain terms is if you have a micropile or a drilled like a auger cast pile, it's customary to put a pile in, do a load test, and then the load test passes, or you get a number that works, that the engineers are happy with, and you adjust the number of piles based on that. Well, then you go ahead and you go across an entire site and put these piles in. But there's nothing to say that when you're on one side of a site, that the soil isn't 30 or 40% weaker in another portion of the site, right? Nobody knows
Right.
that. So, and you can't test every other pile. So we've developed a methodology for inputting the soil parameters, and then the resistance that gets fed back into our program and can give the capacity of the pile during installation
In real time.
in real time.
Oh, that's beautiful. That's groundbreaking. Yeah. I
It means is, you start off, you get a great load test and everything's fine. Well, you might go to another portion of the site and you get into very much denser soils. Well, instead of having an issue or having to go deeper there, you could stop the pile 10 foot less, perhaps. And by contrast, you could go to another section where the soil, for some unknown reason, is very loose, and the output will say you haven't reached capacity. So even though the pile design might be acceptable at 40 feet, in this one area, for some reason, you might have to go 50 or 60 feet to reach that capacity.
Right. And you wouldn't know it otherwise if you did it the traditional method. You're either driving too much or not enough, and we have no idea.
Some may consider it, yeah, whatever, because there's so many safety factors figured into a building foundation. But I'm really excited about it. I'm kind of particular about pile capacity and good load tests and the security of it. So
it's important, and we need as builders, and in the world, but at least in the United States of America, we need to start building some structures and measuring, in my opinion, measuring their life cycle as a function of millennia, not years, but as a function of 1,000 years. We talk about raft foundations. You look at what the Romans did. Those are still around. It's incredible. We've lost some of the concrete technology. So now we got the capacity to build on the knowledge base that we have, which is unbelievable. And I think real-time understanding of what a pile capacity is great. Just great news. And hats off to you again, because there's a lot of patents out there. You were talking about, numbers of patents, and I know a little bit about it. I've got a dozen myself, and my patent attorney always tells me, he says, Kev, he says about 1% of patents that get filed ever turn into anything commercially viable. 1%. So that's the hard part. Filing a patent and having a good idea is just the start.
yeah, I didn't know it was that low.
1%. That's what he told me. 1% is a 1% deal. Yeah, it's very small, and I know you're working on other things too. You mentioned the green way, the building, utilizing the technologies that you have to build better community space, and I'd like to get together with you again and talk about that, because that's right. Really, my line of work is building bridges, big or small. They need foundations, they need superstructure, and they need a deck, right?
Yeah, so our green walk boardwalk is not anything like what you build. It's for people to walk on, right?
Right, different capacity, same stuff though, same.
Yeah, we should get together and talk about that. It's a boardwalk system that's modular and can be put together. One 10-foot section can be put together by a single man, including the decking, in 13 minutes.
Yeah, right. Remarkable. Plus, it's end-on construction. You're building a panel at a time. That's where it's similar to the temporary trestles that we work with every day, and then you get on that with the equipment that's doing the installation, which is key. And then continue. Keep on feeding it from the back, and you build these in nature preserves, or I'm down in Florida here. We've got all kinds of places that we're trying to build to enjoy the nature, and it's really hard to do it in a traditional method, because you end up disturbing the nature as you're trying to preserve it. And the green walk is a great solution for that. And there's people trying to do it different ways, because they've come to us for it, and we're in a much heavier marketplace, and it's requiring foundations that are substantial, and then you can't get the equipment in there. So you're you've become equipment intensive, trying to understand those nuances to help your foundations business, and voila, this other invention comes up. It's like, well, why don't we do this? Because it's hard and no one else has perfected it, right? Um, it's great to get to know you, Ben.
And it's really a pleasure to meet you as well.
Hey, just keep building.
All right.
Thank you.
Thanks.